Hello everyone, in this lesson I'm going to teach you how to draw straight teeth bevel gears with 90-degree shaft angles. Okay, let's just get started. I make a new part. I then open and sketch in the front plane. The most important step in drawing and modeling bevel gears is the first sketch, which defines all the relation between pinion and gears. I assume that the module of the gears are 3 and also the speed ratio is 2. Okay, I need some center line for my drawing. First, I draw vertical and then a horizontal center line. And just for simplicity, I make this point and this horizontal line coincident. Okay, I draw this line which defines the relation between the cone angle of pinion and gear, and for the relation of 2, in fact, for the speed ratio to be 2, this angle must be equal to 26.57. Okay, now I use the mirror command to mirror this line with respect to this line. Okay, then I draw some lines here and define some relations. This line and this line must be perpendicular. Also, this line and this line are perpendicular. Another relation is that these points are symmetric with respect to this line, and also these 2 points are symmetric with the center line. Okay, and now I need some more center lines. One center line is here, which is coincident with this point. So I make a coincident relation. Also, another center line. Oh, sorry. Be careful. These points must be coincident. Okay. Next, another center line. I draw and then make this to be coincident with this point. Good. Then I make some relations. I use mirror command to mirror these two lines with respect to the center line here. Okay. Now I draw the back of my pinion. I draw some lines here. Okay. Be careful not to make unintentionally relations. When you, as you see, when you change your mouse, some relations are made between the sketch entities, but some relations are made without your awareness, and these relations cause difficulties later. For example, as you see, when I move my mouse here, you see a coincident and a perpendicular relation appears here, but I don't want this relation, the perpendicular relation, to be here, so I must change my mouse. I just want to this line to be coincident. Okay, then I draw these lines and then I add some relations. This line and this line are parallel. Also, this line and this line are parallel, and also these two lines are parallel. Okay, so far so good. Let me check my relations. Okay, now I want to define the pitch diameter of the pinion. For this I need 2 points. One point is here, but be careful, here is the midpoint. I don't want it to be the midpoint. So let me first change here. Okay, I put a point here, then I add a relation between these 3 points an intersection relation, which means that this point is at the intersection of this line and this line. Okay, I do the same for the bottom. I put a point here, select these, and then an intersection relation here. Okay, now I can define my pitch diameter of the pinion, which is this dimension, and this must be, well, 60 for these to happen. Okay, I can in fact change my lines so that you see my lines are here. Sometimes you should draw and change your lines so that your sketch be more clear. Okay, now I define this relation and this dimension, which is the width of the teeth. I assume it is 15. You can use any dimension for this. Okay, now I define two more dimensions. The dimension here, which is the back addendum, which is usually equal to module, and our module is 3, so I define this dimension as 3, and also this dimension, which is usually 1.25 multiplied by our module, which is 3.75. Okay, to add more relations, I select this point, and oh, sorry. I select this point, and the center line, and use a symmetry relation, and also this point, and this line, and another symmetric relation. Okay. Very important feature is that you must try always that all your sketches are black. When any entity is black, it means that all the relations and the dimensions are defined. So I have some lines which are not black because I should define another dimension. For example, I define this dimension to be, for example, 60, so that and also another relation here. You see that all the dimensions are now black. Also, I can draw these points so that they will coincide. Okay, we are good now. Our pinion is done. Now I'm going to draw the gear. Okay, the gear is more simple to draw. First, I use the mirror entity to mirror this line, this line, this line with respect to the vertical line here, okay? And in fact, this part is where pinion and gear will mesh. I use a line like this that I will explain why, okay? I draw these lines somehow like this, okay? And then add a relation between these two lines to be, oh, you see the perpendicular relation has appeared here. I don't want this relation, so I delete it. I want this line and this line to be collinear, okay? And also this line must be perpendicular to my pitch center line. Oh, sorry. I define a, in fact, normal relation. Also, I define a symmetric relation between these 2 points, and also here. Okay, I define this distance somehow, for example, 7 to make things better. Okay, then I draw the back of my gear. I draw some lines here. Okay, then here the teeth must be like this, and then these lines get somehow like this, but this line and this line must be parallel. This line must be in fact horizontal like this. Okay. uh, okay, now I define the width of my gear, which I assume to be equal to also 15, and also this line must be collinear with this one. And let me see. Oh, okay, I need another relation, in fact another uh, symmetric relation. As you can see, in fact this point and let me see this point. Okay, this point is coincident here, and uh, these two lines are parallel. Okay, this line, okay, this line with this line and this line. Okay, these 2 points must also be symmetric with respect to this one. Now we are down. Okay, as you can see, all the drawing is black. Let me add another line here, okay, which defines my point here. But as you can see, I should add a relation of collinear so that it gets black. Now I'm done. The pinion and gear are drawn. And now I want to define the pitch diameter of the gear. I put a line here. Also, this line is here. As you can see, when I define this angle equal to 26.57, the pitch diameter of the gear must be 120, which is almost okay. And also it's a driven dimension. As you can see, it's almost 120, which is 2 times the 60, which defines the speed ratio of pinion and gear. Okay, so far so good. Now I use a revolve command to make the uh, pinion and gear. First, I need to draw two lines, a horizontal line here and a vertical line here for defining, in fact, the contours to be revolved. Okay, now I define the revolve command, then I define this contour, and then for axis of revolution, I define this axis. It's done. It's in fact the blank of pinion. Then later we define the cross section of the teeth and complete the model. Okay. I also use the revolve command to define the gear. I open the design tree, click on the sketch and click on the show so that I can see my original sketch here. Okay. Now I again use the revolve command. I use a line like this so that my sketch is active, but be careful. This line must be your axis of revolution, which is this center line. So I define the axis of revolution, and for the contours, I define this contour and also this one. But another thing that you must pay attention is that you should clear this box so that the two bodies are not merged. In fact, we have two bodies in this model, one for pinion and one for gear. If you click this option, the two bodies will be one, but we don't want this to happen, so that I click on it. Okay, so we are done by here. Okay, by now we have our pinion and gear. In fact, our blank pinion and gear, the stock that must be machined so that the teeth will be made on the pinion and gear. In the next video, I will explain you how to model the gears, and then I will mesh the pinion and gear to see what happens. Okay, thank you for your time.